charity that put capital FUN in fundraising, so here we go. It's a real pleasure and also a privilege to be invited here tonight.
Just Jerry brought it into it. Ladies and gentlemen, can you please pay attention for the next couple of minutes? This is pretty important, if you don't mind. Okay, Jerry's got a lot of detailed information to go through, and it's very, very, very important that you understand why you're here. And obviously Jerry's giving up his time, so if you just keep quiet maybe and listen for the next 5 minutes, that would be ideal. Thank you.
So sorry, this is like the science bit in the shampoo adverts. So, as I said, it's a real honour and a privilege to be here tonight and be with you all. I work at the Roslin Institute through in Edinburgh, but I'm actually born and raised just down the water a wee bit in Gourock, so it's always a bit of a pleasure to come back to the West Coast, and hopefully I haven't lost the accent too much. So, you've heard a lot about CF, and that's why we're here tonight. CF is a disease that has a massive impact on the families and patients who suffer from it. So, you probably also all know that it's an inherited genetic disease. So, why does a mutation in a gene, a faulty gene, cause the disease that causes so much suffering? Well, this wee image here on the screen is a picture of lungs, and somewhere in my pocket here I've got a wee pointer. So this is the lungs. And you can see here the airways that come down from your mouth into the lungs, and they branch out like a tree there. And it's a really delicate and fragile system. And you can see this is actually a cast where you put something like latex into a set of lungs and let it harden, just so you can see how delicate all the airways are inside the lungs. And obviously, at the end of all these airways, you've got all these little, they look like little bunches of grapes here. And these are the parts of the lungs where gas exchange takes. That's where you get your oxygen, okay? So if all these little airways leading to these parts get blocked, then you don't get any oxygen, okay? So, all these airways coming down are called conducting airways. And they're lined by things like submucosal glands and goblet cells, and these produce a mucin. And that mucin is really important normally for everyone. You have to produce it. You have to have the lining of your lungs has to have these mucins. Not only that, but the cells that line these conducting airways, they have all these tiny little hairs called cilia. And if I can quickly click on this here, hopefully it'll play. Yeah, you can see on the screen here all these little hairs beating. So your lungs are lined by all these little hairs, and they're like brushes that sweep your lungs clean. And so the combination of these hairs and the cilia and the mucins trap all the stuff you inhale that are bad for you. So particulates, pollution, viruses, bacteria, all the stuff you breathe in that you don't want. These hairs and the mucins that secrete in your airways keep your lungs clean, okay? So the big problem, the gene that affects people with cystic fibrosis, it stops these little hairs beating properly, and the mucin's too thick, and it can't be cleared. And so they end up with lots of horrible bacterial lung diseases. And so instead of having this nice airway here that's clear and oxygen can pass down, the airways get blocked and they have trouble breathing, okay? So it's not very nice at all. So what are we trying to do? We're trying to develop gene therapy. We're trying to use a modified virus to get DNA into the cells that are affected. This is a virus that we tried to use some years ago, and it's brilliant at getting DNA into the cells in the lung, but it doesn't last very long. It only lasts, sorry, these glasses are terrible, for about a week or so. This is another virus. Now this virus, it's rubbish at getting into the lungs, okay? But the way it works, if it does get into a cell, it stays there for the lifetime of that cell. So what we've done, we've combined these two viruses. So now we have a virus that has the properties that are really long lasting. And it's got these proteins on the surface from this virus that are really good at getting it into the cells in the lung. And so this virus is kind of hybrid is really good at getting the DNA that we're trying to get into the cells that we're targeting in the lung. So I'm just going to say a wee bit about some of the work that's been happening in my lab just really in the last 6 months. One of the funding applications that we put in to get funds to do some of this work, and the funders, they were really interested, you really like the idea, but it would be great if we knew that this virus could get into the cells in the human lung. Now, that's what we want to work for, to show that we can do it in the human lung, you know. But we have now started a collaboration with another group in Edinburgh who work in lung transplantation, and they've got this brilliant method. There's a set of lungs in this dome here that are, you know, can be kept alive for about half a day or so while getting them ready for transplantation. So this is a way of keeping lungs alive. So what we're doing, we're working with this team, they can keep lungs alive, but they can only keep them alive for about half a day. But what we can do, we can deliver our virus or gene therapy into these lungs and keep them as long as we can. Then after that, we can take the lungs out and we can cut these little, see like this little cylinder here of tissue. We can put it on a machine with a blade that cuts really thin slices, and we can keep these slices in a dish in culture. It's not come out very well in here, but there's a wee disc there, really thin disc of lung tissue that you can keep alive in culture. And we can keep that going long enough to be able to tell if the virus has got into the cells and is actually making the product, the gene that CF patients would need. And so, using this combination of methods, we now know that the virus, if it gets into the cells in the lung, it can last. We've managed to do this out to about 44 days, but that's as long as we can keep these alive in culture, and there's a limited time span we can do this. So far, we've actually only managed to do it we've been developing this with lungs from sheep, believe it or not, and hopefully sometime in the near future, we'll be able to we should be able to get access to some human lungs that have been deemed unsuitable for transplant, but we can still allow us to do this research. It's a way of us being able to show that the therapy we're testing might actually work in people without actually having to give it to people with all the potential risks that involves. So it's a way of kind of de-risking the project. So why are fundraising events like this so important to us? They're massively important and they make a huge contribution to our research. They help us. A lot of the times, the funding that we get, it takes us a long time to write the grant applications to apply for it, and even once it's been awarded, it takes a long time for all the paperwork to get done and the money to get to us. Now, we've got a big team across the 3 sites in the consortium, in Edinburgh, London and Oxford, and quite often we'll have people that have maybe come to the end of a contract, and we don't want to lose these people. So fundraising from events like this help us bridge salaries of staff from these kind of things. It also helps us to buy equipment. And this wee thing sitting here on a bench in the lab, it doesn't look like much, but that bit of equipment actually cost about £50,000, and Flutterby helped buy this for the lab in Oxford quite recently. And this, I'm just going to quickly, hopefully the sound's going to work on this. This is my colleague in London, Arash. Oh, I'm the wrong button, hold on.
Hi, my name's Arash. I'm a researcher at the National Heart and Lung Institute at Imperial, and my work is focused on monitoring our safety and efficacy outcomes for the viral gene therapy trial which we have planned. So the work I'm doing at the moment is using this new tool called RNAscope to detect very accurately which cells we are targeting with our agent and how good we are at finding those cells. The other thing that I'm looking at is monitoring how closely and how accurately we're able to see whether the vector is shed in different fluids, and that tells us about our safety monitoring in the trial. I'd like to give a massive thanks to Maggie and the Flutterby fundraisers for all the great funding and support that they've given us, and I hope everyone has a great night out.
What we might not be able to get is that the money that's raised tonight and lots of the money that's going to be raised in the future from Flutterby will help to fund Arash's studies and help him gain his PhD, and these kind of things, as I said before, are absolutely invaluable. So before I finish, I'm just going to say one one wee story, so indulge me a minute. When I started my career way back in, I was early in my career anyway, late 1990s, and I was working in a lab in Edinburgh with in Professor David Porteous' lab, and we'd just done our first gene therapy trial for cystic fibrosis. And David was invited to go and give a talk in Spain, in Bilbao, at the Spanish equivalent of the CF meeting. David couldn't go, and he asked me if I would go and present the work. So, and the Spanish CF people, they also invited my wife to come along, to come to me. So while I was working hard at the meeting, my wife was really entertained quite well by the CF Trust. She was taken around the city, the Guggenheim Museum, and nice lunches and stuff. And she was accompanied by the wives of two professors, Professor John Dodge and Professor Niels Hoybe, who are two of the real pioneers of CF treatment. And they said to Karen, how long has your husband been working in CF? And at that time it was about 5 years, and they said, well, you realise that'll be him for life. And they'd witnessed through their husbands that once they got involved in the whole wider CF community, that it was actually then really hard to move to any other areas of research. And so here I am, 20 years later, still working in CF. And so meeting patients and families like Kelly and Maggie, and seeing their drive and commitment to support our research. The patients take part in our clinical trials. They trust us that the work we've done has been done properly. They're taking risks when they enter clinical trials that the therapies we're developing, at the very least, aren't actually going to make their symptoms any worse. And so, we are so grateful. And really it's the efforts of the CF patients and the families that, for us, make it so much more than just a job. Okay, and I'm going to stop there and let you get on with the night. Thanks.
Ladies and gentlemen, please give a round of applause for Jerry. Very informative. Thank you very much. Now we have Jerry. Now we've also got a guest speaker coming up.